All right, we are going to continue looking at some formulas by looking at the sum and difference formulas in 5.2. So one of the formulas I have, don't worry, I'm going to let you get them all done at once, but is the cosine of alpha minus beta. And alpha and beta can be whatever they want. The idea is if I have something with cosine, two things separated by a subtraction sign, that can become cosine alpha, cosine beta, plus sine alpha, sine beta. All right, this is an example, all right, and this will allow us to find angles that perhaps we couldn't find before. Now I'm going to give you all 6 of them right now, and then what I would have you do is those of you that want to take notes, I would pause the video, get all 6 of these down, and when you have them all down, then unpause the video and I'll go over them. Okay, so hopefully when you're writing down, we saw some similarities between the cosine formulas, the sine formulas, and then the tangent formulas. Notice cosine is always starting cosine alpha, cosine beta, cosine alpha, cosine beta. Right? The only difference is the plus and the minus. Depends on the plus or minus there. Same thing with sine alpha, sine beta. It always starts the same. Right? It's going to be different than the cosine formula, but it's going to start the same. Where it's different in our subtraction signs. And the same idea with the two tangent formulas. Right? So the idea would be, if I had, for example, something like this. Maybe I said, what is the exact value of the cosine of 75 degrees? You don't have the ability to find the exact value of the cosine of 75 degrees. But, if I wrote this, if I wrote the cosine of 120 minus 45, you can now find the exact value. And 120 minus 45 is 75. So this essentially will find me the cosine of 75 degrees. So we just have to use our formula, right? So you're going to have to look back and forth on these. I don't expect you to memorize these instantly. But this will be the cosine of 120 times the cosine of 45 plus the sine of 120 times the sine of 45. All right. Now, maybe you need to draw some triangles in. Maybe you don't know off the top of your head where 120 degrees is. We're going to end up with a 60-degree angle in the second quadrant, where root 3, negative 1, and 2 is how I label my picture. And then for 45 degrees, we'd have a 45, 45, 90 triangle in the first quadrant. All right? So now if I look at what I have, I can find the cosine of 120. Cosine is my x over my radius, negative 1/2. Cosine of 45 is root 2 over 2. Sine of 120, well, that's my y over my r. And then the sine of 45. So my common denominator is going to be 4, and I'm going to have negative root 2. Root 3 times root 2 is root 6, plus root 6. So that is my exact value. So if we did really well in chapter 4, all we're doing now is we got some other formulas that we are going to have to know, but then all we're doing is like 4 exact value problems in one. And so we're just taking what we did and we're just expanding on it. So now I want to look at a sine formula. All right? Excuse me. So now if I'm looking here, now I'd have the sine of pi over 3 times the cosine of pi over 4, that's my new formula, plus the cosine of pi over 3, and the sine of pi over 4. We have my 45-degree triangle. That's what pi over 4 is. That's what I have in red. All right. So if you need, just to reiterate, pi over 3 is going to be a 60-degree angle in the first quadrant. So if you got to make a triangle label, then you should do that. Now the sine of pi over 3 is the sine of 60 degrees. That's root 3 over 2. Cosine of 45 degrees, or pi over 4, is root 2 over 2. Cosine of pi over 3 is 1/2. And then the sine is root 2 over 2. So again, my common, it's going to end up being 4 as my denominator. And now I'm just going to have root 6 plus root 2. Yep. Oh, screwed up. Hold on, one mistake. This is why I need you in class. I wrote the formula down wrong. That's a subtraction sign. For with the sine formula, which means that's a subtraction sign as well. All right, so look at that. Ended up actually being the same answer. Isn't that special? Okay, so sorry for my mistake there. Sine minus sine, right, stays minus. So that was my mistake. So let's look at a tangent one. We've done a cosine one. We've done a sine one. Let's look at a tangent one. Now maybe you're not great with radians. If you're not, the first thing I would do is I would convert these to degrees always. 5 pi over 3 is 300. So if we're not good with radians, let's convert it to degrees. So that really, for our problem now we have the tangent of 300 minus the tangent of 45 all over 1 plus the tangent of 300 times the tangent of 45. So I'll draw 300. Right, 300 is going to go around. You're going to be in the fourth quadrant, 60 degrees. Alright, so that's going to be my triangle. So tangent 300 is actually going to be negative root 3. Minus the tangent of 45 is 1. Right? It's an isosceles triangle. So go back up. Look at my red picture. 1 over 1 is going to be 1. Right? Tangent's y over x. So on the bottom I have 1 plus. I'm going to have negative root 3 times 1. Because now it's multiplication on the bottom. So I get negative root 3 minus 1 over 1 minus root 3. So now what we're going to have to do is now we've got to multiply it by the conjugate so I can get rid of that radical in the denominator. So I'm going to multiply by 1 plus root 3, 1 plus root 3. So now we're just getting back on our algebra skills. So negative root 3 times 1. Negative root 3 times positive root 3 is a negative 3. Negative 1 times a positive 1. And negative 1 times root 3. And then on the bottom, I'll end up with 1 minus 3. So I combine my like terms. Negative 3 and negative 1 is negative 4. And then I have negative 2 root 3 over negative 2. That's a lot of negatives. So I would want to simplify that. So negative 4 divided by negative 2. Negative 2 divided by negative 2 is just a 1. So in its simplified form, all I get is 2 plus root 3. Okay, so I have now walked through a sine, a cosine, and a tangent. I would like you to take a couple minutes, pause, see if you can write out this formula and do the cosine one. Okay? Excuse me. Alright, so hopefully you kind of could look back at the formula and you get cosine of 2 pi over 3 times the cosine of pi over 6 plus the sine of 2 pi over 3, the sine of pi over 6. Right? We can't get the problem right if we don't write it correctly. 2 pi over 3 is 120 degrees. So I'd end up with negative 1/2. I guess pi over 6, that's 30 degrees. So I'd have negative 1/2 times root 3 over 2. Plus the sine of 2 pi over 3 is a positive root 3 over 2. And the sine of pi over 6 is a half. So in this particular case, I end up with negative root 3 over 4 plus positive root 3 over 4. Well, that's just 0. All right. So that's a couple, 4 examples of taking and expanding and finding out what the exact value is. So we're just going to do a few more the opposite way. So if I'm in reverse order, the problems are actually going to be a lot shorter. Right? So those of you that are zoning out, give me your attention for just a little bit longer and we'll be done with video 1. When I look here, now I have the cosine of 100, cosine of 55, plus sine of 100, sine of 55. Well, I'm hoping we realize when it goes cosine, cosine, that we know that we're dealing with a cosine problem. Because I have a plus here, that means I really have a minus. So, I'm really find the cosine of 45 degrees. We know that. That's root 2 over 2. So realizing which formula goes with what is going to take some time. But when we're going in the reverse order, it's going to be a lot quicker if we can recognize the formula. So now I have sine of 7 pi over 12, cosine of pi over 12. When I alternate between sine and cosine, that means I'm doing sine. So I have sine of 7 pi over 12. I have a minus here. I've got to realize that means minus pi over 12. So really you're doing the sine of 6 pi over 12, which is the sine of pi over 2. But what is the sine of pi over 2? Yeah, just 1, right? Pi over 2 is right here. That's the order pair 0, 1. My sine value and my y value is 1. All right. Why don't you pause the video one more time, try number 6, and then we'll go over it together. So hopefully we realized we had to be doing a tangent problem. It ends up being tangent of 50 minus 20. So we're finding the tangent of 30. So I'd have 1 over root 3, because tangent is y over x. So when I rationalize that, I get root 3 over 3. All right? I think this is a good time for you to stop and do some problems. Hopefully, you're in class, and hopefully then it's a lot less boring than the video. But here's the start of lesson 5.2. We have more videos to come, 2 more videos exactly. So take some time, do the first part of the lesson.